Today we're going to cover section 4.1, polynomial functions. A polynomial is a phrase, a mathematical phrase that has real number coefficients and variables with positive integer exponents. So it's really easier, like down here in example 1, we're going to determine whether each function is a polynomial or not. It's honestly easier to describe what a polynomial is by explaining what a polynomial isn't. So the coefficients are the numbers in front of the letters. Those have to be real numbers. So that means that a polynomial cannot have any i's. So you can't have any i's. No imaginary numbers. And then the exponents have to be positive integer exponents. That means no negative exponents and no decimal exponents. All right. Standard form just means that the largest exponent term is written first and then in decreasing order. So if you've got an x to the fourth somewhere in there, it needs to be the x to the fourth first, then the x to the third, then the x squared, then the x, then the number. So largest exponent term first, and then the rest of them in decreasing order. So in example 1, they're asking, they're going to ask, is it a polynomial? So yes or no. If it is a polynomial, we need to write it in standard form, so largest exponent term first, and then in decreasing order. Then they want us to state the degree, the type, and the leading coefficient. So the degree is basically the largest exponent. So if there's no exponent, or if there's no x value at all, a 0 degree means that there's no x. A first degree means it's just plain x. A second degree means that the largest exponent is a square. A third degree means the largest exponent is a cube. And a fourth degree means the largest exponent is a 4. No x, a 0 degree, is called a constant because the function is just a constant number. First degree is a linear function. Second degree is quadratic. Third degree is cubic. Fourth degree is quartic. So you're going to want to have this out when you're doing this stuff. This other stuff is really just examples. That the first 2 columns and then the stuff that I wrote over there is really what you're going to need to have when you do these. So if you don't have this notes packet, which is totally fine, I would at least pause the video and write this stuff down somewhere that you can reference back to, so that when you're trying to do these problems, you have that information in front of you. So this first one, 5, -2, and 8, those are all real numbers. The exponents all look positive. So yes, this is a polynomial. Standard form, we would put the -2x cubed first, then the 5x, then the 8. Then we want to state the degree, the type, and the leading coefficient. The degree is 3, the type is cubic, and the leading coefficient, that's the one thing we didn't talk about. The leading coefficient is the number in front of the term that has the largest exponent. So in this case, the leading coefficient is -2. And I'm going to highlight these things to help us. So the degree is the largest exponent. The leading coefficient is the number in front of the term with the largest exponent. And then the type relates to the degree. Third degree, cubic. Okay, B. A lot of people instinctively say no to B because they see that square root of 2. But you can do the square root of 2 in a calculator. It's a decimal, but it is a real number. So even though this one looks funky, yes, it is technically a polynomial. Standard form, we would put the square root of 2x to the fourth first, then minus 0.8x to the third, minus 12. The degree is 4. The type, that makes it quartic. And the leading coefficient is the square root of 2. C. C is not a polynomial. Because it has a negative exponent, it is not a polynomial. D is not a polynomial. Now, some people have said, well, if x was a positive number, then it would be a polynomial. But the problem is we don't know what x is. Your exponent has to be a positive integer. It can't be an unknown. Because the exponent is unknown, it is not a polynomial. You have to know what all the exponents are to make it a polynomial. E, definitely yes, that is a polynomial. Standard form would be negative 3x to the fourth first, then x to the third minus 6x. The degree is 4. The type is quartic. And the leading coefficient is negative 3. Once again, the degree is the largest exponent, and that also relates to the type. The leading coefficient is the number in front of the term with the largest exponent. And then F, yes, there's decimals, but that's okay. They are all real numbers, and the exponents are all positive integers. So yes, this one is a polynomial. Standard form, we would put the fourth term first, so 3x to the fourth minus 1.6, that's a funky looking 1.6, x to the third minus 6.7x squared plus 7. The degree is 4, so the type is quartic. We had a lot of quartics, and the leading coefficient is 3. Evaluate the polynomial functions for the given values of x. So here's a polynomial. They want us in every single one of those x's to put 3. They want us to do f of 3. Plug 3 into all of the x's. My biggest suggestion here, you can use your calculator if you are big into parentheses. Everywhere that you see an x, put parentheses around it. So 2 parentheses 3, close your parentheses raised to the fourth, minus 8 parentheses 3, close your parentheses squared, plus 5 parentheses 3, minus 7. If you plug that into your calculator exactly like that, it will give you the right answer. I'm going to show you how B should be, and then I'll pause the video and we can enter that in our calculators. In B, you would want to do negative parentheses, and we're plugging negative 4 in. Actually, I'm just going to write a skeleton like this. So I rewrote the polynomial, taking the x's out and putting parentheses in their place. And then I'm going to take this negative 4 and stick it into those parentheses. And if you plug that into your calculator, it will give you the right answer. So now pause the video, take a moment, plug that in your calculator and try. Okay, example 2a, you should get 98 if you plugged it into the calculator correctly. 2b, I plugged it in 2 ways. The first way I used the parentheses as I said, and I got 121. The correct answer here is 121. If you put it in your calculator without parentheses, you would have gotten 25 because your calculator is doing the exponent and then sticking the negative on the front, which is not always correct. That's not what we're intending. You want to square negative 4, not do 4 squared and then stick a negative on it. So the parentheses are ridiculously important, especially when you're dealing with negative numbers. Now the first one, because it's a positive number, if I had entered this without parentheses, it still would have been fine because 3 is a positive number. But if you're plugging in a negative number, you really need those parentheses. Okay, next we're going to start getting into graphing polynomial functions. We're not going to fully graph them. We're just going to talk about end behavior. End behavior is what the ends of the graphs do. So what does the left side of the graph do and what does the right side of the graph do? And we're going to split this up and look at it by degrees and leading coefficients. So first let's talk about odd degree. An odd degree polynomial is a polynomial where the largest term is x cubed or x to the fifth or x to the seventh. Anytime your largest exponent is an odd number. So you might want to write next, well, if you're doing this on your own, I'm going to kind of do it like this. If you're doing this on your own, I would make yourself a chart like this. And this is odd degree, positive leading coefficient. This next one is odd degree, negative leading coefficient. Okay. Odd degrees, the ends point in opposite directions. So I want you to write somewhere in there, odd degree, opposite. Odd opposite. The two ends are always going to point in the opposite directions. And if you could see me in person, I'm basically like, if I point one finger up, the other finger's down, and so on. The leading coefficient tells you what the right side of this graph is going to do. So if it's a positive leading coefficient, the right side is going to go up, the left side is going to point in the opposite direction, and then there's going to be something connecting those in the middle. If it's a negative leading coefficient, the right side goes down. So the positive leading coefficient, it relates to the right side. The left side would go in the opposite direction, and then something would connect those in between. It might be one hump, it might be two humps, it might be 10 humps, whatever. Now let's look at even degree. Even degree, the ends are going to point in the same direction. The leading coefficient is still going to do the right side. So in even degree positive leading coefficient, the right side is going to point up. The left side is going to do the same thing and also point up. And these two things might connect like that, like a parabola, like x squared. 2 is an even number. Or there might be extra humps in there and it might make it kind of W-shaped. Even degree with a negative leading coefficient. The right side is going to point down, the left side will also point down, and there will be some sort of connection in between there. It might just be a parabola, it might be a W shape or an M shape, something will connect them in the middle. But I don't really care about the middle, I care about these ends. Describe the end behavior, basically make a sketch. And we're just going to do something like, this is how I did it on the test. Odd degree positive, odd degree negative, even degree positive, even degree negative. I just want you to point at what the ends of this are going to do. So A, this is a even degree with a negative leading coefficient. Negative leading coefficient means the right side is going to point down. Even degree means the left side is going to point in the same direction. B, we have an odd degree. So our degree is odd. But we have a positive leading coefficient. So the right side is going to point up because it's a positive leading coefficient, but that odd tells us that the left side is going to point in the opposite direction. C, we have an even leading coefficient. That 2 is an even number, so the ends are going to point in the same direction. The leading coefficient is positive, so I know the right side is going to point up, the left side will point in the same direction. D, our degree is odd. 5 is an odd number, so our degree is odd. Our leading coefficient is positive, clearly negative. So the right side will point down and the left side is going to point in the opposite direction. So I always start with the leading coefficient to tell me what the right side is going to do. And then I look at, is it odd or even? Is the other side going to do the same or different? And here's the one that you're going to see on your assignment, because this example 3 on your assignment was weird, so I skipped those on your assignment. You are going to have problems like example 4 on your assignment. Describe the degree and the leading coefficient of the polynomial. The reason that we cover this is that you can match a graph to a function sometimes only by this information. So this, I see that the right side points up, so I know that it has a positive leading coefficient. I see that the left side points in the opposite direction. That means it's an odd degree. So pause the video and try B on your own. The right side points down, that means a negative leading coefficient. The left side also points down, so that means that we have an even degree because the ends are pointing in the same direction. Okay, that is it for part 1 of your notes. Your assignment is in Big Ideas Math, so make sure you go to Clever and then Big Ideas. And it is 4.1 part 1.